Wait. It says the mic is on, but it's not picking anything up. Hello? Is it not picking it up? Hello? Hello? Can you hear anything from it? Okay. For some reason it's being.
It's like quiet, but it's there.
I don't know why it's. Options. Okay.
Maybe you need to blow it in like a cartridge, but just again.
Yeah. Hello? There we go. Now it's picking it up. Hello? Hello? Okay, well it did, and now it's not. Okay, now it is.
So weird.
Maybe I'll just leave it up there and it'll be fine. Okay, it looks like it'll be fine.
I think you have to like literally be speaking into it, I guess.
Let's see, can I hear it from my phone? Why can't I hear it from my phone? Oh well.
You'll just have to listen.
Can I hear it from my phone now? Hello? Hello? Okay, I can hear it. It's very quiet, but I can
Yeah.
hear it. All right. Ooh. Actually, about as much as I expected. Right. This. Okay. Let's see. Not here. Probably easier for me to mark everyone that is here. Easton is not here. Garrett, right there. Let's see. Nolan, not here yet. Benton is not here. Jenna, there. Ryla is here. Mateo is not here. Gabby, right there. Charles is here. Lizzie is not here. Brandon is not here. Ellis is here. Peyton is here. Risha is here. Carter is not here. Abby is not here. Is that her stuff? Clayton is not here. Noah is here. Yvette is here. Logan is not here. Angel is not here. Mom is not here. Sydney is not here. Wyatt is here. Stuffa is not here. Cannon is here. Yeah, the market. There we go. Callie is not here. Emily is not here. Liam is here. Cameron is not here. Jamie is not here. And Evans is not here. But Logan is here now. And everyone else is not. Alrighty, how are we doing today, everyone? Weather's nice. It's a little hot, but it's nice. It's a little humid though too because of the rain and everything. So cool, cool. Anyone have any cool spring break plans? Y'all have no lives.
Home sleep.
Yeah, sleep is gonna be nice. Cool.
Sleep again.
Yeah.
I'm like, I miss my dogs. I miss my cats. They got the cat. And the dog we've had for a while. This cat. And she's like, every time I come back, she don't.
Yeah.
And also it doesn't mean that she's like, they don't like that and bigger. She's like, I like the small.
For the first about 2 years that my wife and I were together, her grandma's dog didn't know who I was every time that I would see it. Like she would try to attack me. And then out of nowhere, it switched. She loves me now. Animals are weird. Cool.
She's so soft. And
Yeah.
She's a Bengal, so she's like every time we're waiting for her to start like able to start like running around because she until she has energy, she just too skittish to not to show off her energy. It was funny though because my mom realized that she was a man. She was like, "Hey, things are nice and deleted."
Cool, cool. Okay, Emily. Is present. Alrighty. I haven't graded the test yet. Every time that I give a test, the first thing I look for is the bonus question answers. Some of them were really freaking good. Shout out Liam, who taught himself part of calculus and then put that on the bonus question. That was
I get +10.
yes. Yeah, you got 10 bonus. I was tempted to give you more bonus points, but I was like, if I give you too many, then it becomes unfair. But yeah, it was a great bonus response. Several really good bonus responses from y'all. So do y'all like that question? Like as a bonus question? It gives you a chance to kind of flex a little bit. And I really like that. And I feel like that also gives y'all a chance to feel smart. Like, here's something I know that other people don't know. And it's like, you're right. It's really cool. I really, really enjoyed the responses from the bonus question. So thank y'all very, very much. I very much so enjoy when y'all fill those out. Cool, cool. Any questions about anything before we start digging into graphs and lines? This is again just going to be a review from college algebra, or if you took business calculus, this is also very, very review for business calculus. So any questions about anything at all? Homework, tests, anything like that? Cool, cool. All right, Liam, you didn't have a question, did you? Okay, cool. Cool. So yeah, we're talking about graphs and lines today. So this is just going to be a review, really mostly of linear or quadratic functions. Some power functions here. And yeah. And then we'll talk a little bit about supply and demand. It's not too much, and I don't want to go too in depth with it because a lot of this is review, and a lot of it's just carried over from the previous section, and it's also not super important for the class material. Like it's such a really small chunk, and I really just want to get this out of the way so that when we come back from spring break, we can start dealing with what is basically linear algebra, how to solve multiple equations at once. Which is, in my opinion, one of the more important parts of this class. Cool, cool. I like standing. I feel like I'm in a standing mood. If that stresses any of you out, I can sit down, but if not, I'm going to stand. Cool. All right. So we're talking about equations, and then we've got some definitions to go along with those. A point in the rectangular coordinate system is represented by an ordered pair. What's meant by rectangular coordinate system is that there are other ways that I could describe points. If any of y'all know an engineer or anything like that, you can ask them about these coordinate systems. Most of the time when we talk about points, I have a point here labeled by X, Y. And it's basically just an arrow from the origin out to that point. Another very common, so these are called rectangular. Rectangular coordinates. Another very popular way to describe points, especially when we're talking about things in physics, is with spherical coordinates. So we talk about so when we talk about a point, we talk about how far away from the origin it is, plus what angle it makes with the x-axis. This is called polar coordinates. Any point here that would be x, y, we instead describe as the radius from the origin and the angle that it makes the origin. You can also do this for higher dimensions. In 3 dimensions, you typically call it rho, theta, and phi. So it makes an angle, it makes a distance from the origin, an angle in one direction and an angle in the other direction. There are other coordinate systems. Typically, physics is defined in a set of 18 different coordinate systems. Most people only use 3. But that's when it says rectangular coordinates, that's what it means. It does, like, you draw rectangles to define points, essentially. That splits the coordinate system or the plane into 4 quadrants. Quadrant 1, x positive and y positive. Quadrant 2, where x is negative and y is positive. Quadrant 3, where both are negative. And quadrant 4, where x is positive and y is negative. It's just useful to kind of visualize it that way, because if I start talking about points and I say, take a point in quadrant 2, for instance, then you know, okay, I'm dealing with negative x values and positive y values. We can graph linear equations. We can like plot out a chart of the points and then put those on a coordinate system. For instance, if our function is x plus 3y equals 5, I can rewrite this as y equals mx plus b. I'm just solving for y here. So I move the x over, 3y equals negative 5 minus x, divide by 3. So y equals negative 1/3 x minus 5 over 3, for instance. This is what you did at the beginning of the second Excel assignment. Solving for y is a very common thing to do when you're given linear equations like this. Cool, cool. Now I will sit down because I got the energy out. So for instance, if I plug in 0, I'm going to get a 0 here and a negative 5/3. 5. What can I plug in to get 0? Well, I could also like resolve this for x instead. X equals negative 5 minus 3y. So if I have a 0 here, I have a 0 for y. That means I get negative 5. If I plug in negative 5, I get 0, and that makes sense. If I plug in negative 5 here, I get 5/3 minus 5/3 is 0. So that does make sense. If I want 1, so I plug in x equals 1, I get negative 1/3 minus 5/3. It's negative 6/3, which is negative 2. And then what can I plug in to get negative 1? I put in negative 1 here. Negative 5 plus 3 is negative 2. I have to think about that for a second. And then I could plot these points. Choose at least 3. I'm going to pick these 3 points right here because I don't have to deal with any gross fractions. And I'm going to let my coordinate system be like this. So I've got 1, 2, 3, 4, 5, yada, yada. If my x is negative 5, my y is 0. If my x is 1, my y is negative 2. If my x is negative 2, my y is negative 1. And then I can connect these, and we see I get the function of a line. Cool. And just checking this negative 2, negative 1. So that point should be there. My bad. Ignore that point. So I can like throw a couple of points into a function, get to those points, and plot it. One thing I'll note, maybe I'll write it here up at the top. Linear functions need 2 points. Quadratic functions, which are the 2 that you'll deal with the most, these require 3 points. Cool, and then I can graph them all nice and neat. Linear works for any 2 points. Quadratic, you technically can graph it with any 3 points, but there are points that if you pick them, it works a little better. Specifically, if it has roots, you can plot the roots and then find the axis of symmetry, which you learned in college algebra, is like where the vertex is, the line that passes through that, and you can plot it like that. Cool. So a linear function is anything whose graph is a line, like a straight line. So is this first one linear? Why not? Yeah, it's a curved line. It's not a straight line. Nope. Not straight line. This one, another way to describe a linear function is any function that's of the form y equals mx plus b, or just whatever variable. Specifically, it's what we call a first order polynomial. The exponent on your variable, the highest exponent available, is +1, which means that we don't have to write it, right? Anything to the first power is itself, so I don't have to write it. So here is this linear. Yes, it's of the form y equals a number times the variable plus another number. Yes, I'll just say first order polynomial. And then what about this one? This one might be a little trickier of one, but it's not, right? It's not of the form something times the variable, right? We're dividing by the variable. So no, this specifically is a rational function. Cool. And then what about this last one? Yeah, it's a straight line. Yes, straight line. Cool. And then we've got a couple more examples. This is, for example, y equals, it's written out weirdly, but 2x squared plus 3. Is this linear? No, the highest order is greater than 1, right? It's a squared. This is a quadratic function. Not linear. Cool. Same thing with f. What kind of function is this, if anyone remembers? This is an exponential function. So that's an exponential function. This one, we just want to make sure that the change between the values is the same. The change in my input value is always 1. The change in my output value is always 3. So yes, between any two y and x, this equals 3. So the change between points is always the same. The slope between 2 points is always the same for these 3 points at least. It says here the function for the area of a triangle. This is an interesting question. When we talk about the area of a triangle, a equals 1/2 base times height. This isn't a linear function, right? I'm multiplying two things. Like if for instance, like I fix the area, I try to talk about the base or the height, I can't get a linear function. So no multiplying variables. Right. This would be like if my function, for instance, let me kind of explain this one out a little more. A equals 1/2 base times height. My variables are base and height. Let base maybe be x and height be y, my variables. So it's the same thing as a equals 1/2 xy. If I try to rewrite this in the form y equals 1/2, or y equals mx plus b, what happens? I get y equals 2a over x. This is a rational function, right? I have to divide out this 1/2 x over here. So this is a rational function, not linear. It depends on two variables is the problem here. So this is not linear because it multiplies those two variables together. If, for instance, I fixed the height or the base and let the other one vary, then it would be linear. But as of now, as of how it's stated, since they're both variables, it's not linear. Recall, if a linear function is written in this form, then m is the slope and the point 0b is the y-intercept. So it says, for instance, find the slope and y-intercept of this. What's the first thing we should do with this equation? Charles. Solve for y. Is that what was said over here? Yeah, exactly the same thing. We're solving for y here. Subtract 2x. So negative 3y equals negative 2x plus 8. And then divide by negative 3. So get y equals 2/3 x minus 8/3. Pretty straightforward. At this point, you should be able to more or less solve linear equations for y in your sleep. Like, it's really, you move everything over to one side and you divide. That's it. Cool. And then we're finding the slope. This is our slope. Slope is always just the number that multiplies x, or whatever your variable is. And the intercept, it's always 0 for the first coordinate, and then this point right here, negative 8/3. The reason it's always 0 for that part right there is that the intercept is defined as the point where x equals 0. When x equals 0, I'm at the origin on the x-axis, and the function's passing through the y-axis. So it's always going to be the point where x equals 0. Remember, in general, the y-intercept is at x equals 0. The x-intercept is at y equals 0. And it says that exactly right here. It says that in the next two lines. Each point on the graph that lies on the x-axis is y equals 0. So to find the x-intercept, set y equals 0. To find the y-intercept, set x equals 0. Another maybe important, oh, it says right here. What is the maximum number of x-intercepts a line could have? So this is linear, line, linear function. So how many times can one line, a linear function, pass through the x-axis? Just once, right? No matter how I draw a line, there's only one way it can pass through the x-axis, unless the line is on the x-axis. If the line is the x-axis, the answer is infinity. But for standard linear function, the answer is once. What about y-intercepts? How many times can it pass through the y-axis? Once. So I should say here once or infinity, right? If it is itself the x-axis once, no matter what. That's for any function. Why is it the case that a function can only pass through the y-axis once? What is one thing that when I draw a function, it has to satisfy? Not just a linear function. Like if I draw any function, yes. Vertical line test. If a function were to pass through the y-axis more than once, it automatically fails the vertical line test because it's passing a vertical line more than once. So any function can only have one y-intercept. Just in general, any function. What is the only type of line that may not have an x-intercept? This is an interesting question. There's not only one type of function that doesn't have an x-intercept. There's a couple of types of functions that don't have x-intercepts. The functions we're interested in are rational functions and even power polynomials. Right? Remember, a rational function just typically looks like this. Right? I'll draw that on the paper over 2. This is a rational function. An even power polynomial looks something like this, or maybe this. It could even look like this, but there's a chance that it doesn't pass through the x-axis. There are also other examples, for instance, exponential functions. An exponential function can look like this. It doesn't pass through the axis right there. Cool. Specifically, the statement is a number to an exponent can't be negative, right? And that makes sense because even if you put in a negative exponent, it's still just a fraction. That's 1 over to the positive exponent. It says, what is the only type of function that may not have a y-intercept? There are no functions that can't have, well, I take that back, rational functions. Right? How I drew this rational function over here, let's just say that f of x equals 1 over x. I can't plug in 0, so it can't touch the x-axis or the y-axis, and I can't have it equal 0, so it can't touch the x-axis. It can't touch either axis here, right? It can't equal 0, and I can't plug in 0. So rational functions are the only functions that can't pass through the y-axis, or at least in that statement they can. There are ways to make it pass through the axis, right? And for instance, I wrote it as 1 over x plus 2, it instead looks something like this, where this is at -2, right? So it can pass through the y-axis here, but that's only if I shift it over. Otherwise, just in general, 1 over x doesn't pass through either axis. Now it says to find the x and y intercepts and graph them. For a linear function, I really only need the x and the y intercepts. Those are 2 points, and it gives me a line. So the x-intercept is at y equals 0. So -2x equals 12, x equals -6. So at y equals 0, I go to x equals -6. My bad, that's the other way around. And I get a point there. Ignore that one. And then y-intercept is at x equals 0. 0 there just means 5y equals 12, or y equals 12 over 5, which is 12 divided by 5 is 2 2/5. So that's 2.4. So x equals 0, that's right here. My y is 2.4, so about here. Cool. And then I can just connect them. And that's the graph of my line. So it's really useful, instead of plugging in random values, I just set each of the variables equal to 0, solve for the other one, and I can plot any linear function that way. It's really straightforward. I don't have to plug in and solve for anything. I set this equal to 0, then I divide, or I set this equal to 0 and I divide. Pretty straightforward. I should also say that, okay, yeah, never mind. The way it was on the screen, I moved it just slightly to where for some reason the equal sign turned into a negative sign and I got confused. We're all good. Then state the slope. I can find the slope here by just finding change in y over change in x, or I can rearrange this. Yeah, it doesn't pass through points nicely. So my change in y is y2 minus y1, and the change in x is x2 minus x1. My y value, oh, let me put here. My y value here is 2.4. My y value here is 0. My x value here is 0. My x value here is -6, so that becomes +6. So I get 2.4 divided by 6, which is 0.4 or 2/5. Cool, cool. You could do this with your calculator if you wanted to. All is fine and dandy there. What I could also have done.
You could just do it by getting y by itself.
Yeah, I could. That would maybe require maybe not require a little more, but yeah, you can do it by getting y by itself. 5y equals 2x plus 12. Y equals 2/5 x plus 12 over 5. So I see I get the same answer. I get 2/5 for both of them. So either method you want to do is fine. Since I had all the information up here that I already needed to just find the slope this way, I could have done it like that. But more than likely also what it would have wanted is for you to rearrange and solve for y. Cool, cool. I also noticed that I get the same y-intercept. I get 12 over 5, 12 over 5. Cool. All right. So I'm guessing that these are just functions. Okay. Y equals -3. I go to the point where y equals -3, and then I draw a line. That's the function there. What is the slope of a function like this? 0, right? If I pick any 2 points, maybe like this, the change in y is 0. The y value doesn't change, even though the x values change. So I get 0 over a number, which is always 0. Cool. If you don't remember which one it is, like which function has slope 0 or which one has this one is undefined, just pick 2 points on the line and try to find the slope between them. If I pick any 2 points on this line, maybe these 2 points, I will get change in y is 3 minus 0. Change in x is 2 minus 2. I get 3 over 0. Division by 0 is undefined. So that's why the slope of this line is undefined. Here, again, I pick any 2 points. The y value here is -3 plus 3, because I get minus another -3. Then my x values are 0 minus maybe 3 there. I get 0 over -3, which is 0. That's just for any 2 points. I just conveniently happened to pick a point that was also -3. This has nothing to do with the -3s on the top. So horizontal lines have 0 slope. Vertical lines have undefined slope. They're undefined. They're not functions. They fail the vertical line test too, because they themselves are vertical lines. All right. And then another function here, -3/4 y equals x. Remember, to divide by a fraction, I multiply by its reciprocal. So if I multiply both sides by -4/3, what happens? On this side, I get -12 over -12 y equals -4/3 x. -12 over -12 is 1. So I get y equals -4/3 x. Just in general, though, I'm multiplying by the reciprocal. Since it's negative, I also include the sign there. So I just multiply by flipping the fraction upside down. So my graph is y equals -4/3 x. There's no intercept, right? There's no plus anything. So it passes through the origin. And then I'll go up 1, 2, 3, 4, 1, 2, 3. And it passes through that point, keeps on going that way, and keeps on going that way. Cool, cool. And then the slope is just this -4/3. It says, note, horizontal lines are in the form y equals b and have a slope of 0. Vertical lines are in the form x equals a and have a slope of undefined, which is what I just said there. There's several different ways to determine the slope of the line. I can either look at the equation or sketch its graph, study the graph of the equation, or use a pair of points and then do the slope formula. We've already covered the first two, and we define the slope here as rise over run. This is anytime I write change in y over change in x, which is y2 minus y1 over x2 minus x1, that's what it's talking about. Y'all have seen this right here, though, right? Very hopeful that everyone has seen the change in y over change in x. That's how it's usually described. It also says to make sure that you keep your points in order. Don't mix up the x1 with the y2 or the y1 with the x2 for any reason. So I can find the slope between the given points. For instance, here, I maybe let this x1, y1, x2, y2. Then slope m, change in y over change in x, is y2 minus y1 over x2 minus x1 is 4 minus 1 over negative 3 minus negative 4 equals 3 over, this is negative 3 plus 4, which is 1, which is just 3. Cool, cool. Again, we're really just reviewing some of the stuff you've seen in college algebra or high school algebra or anything like that. B, I can do the same thing. 10 over 3 minus 1 over 3 divided by 5 over 4 minus 3 over 4. If they have the same denominator, I can just subtract fractions. So this becomes 9 over 3 divided by 2 over 4. This is 3 divided by 1/2, which is the same thing as 3 times 2, which is 6. Again, straightforward. All I'm doing is basic arithmetic, subtracting fractions and the dividing. Again, dividing by 1/2 is the same thing as multiplying by 2, so it works out. And then C, another really simple example, but we'll notice something kind of tricky about it. 4 minus 2 over 1 minus 1, 2 over 0 is undefined. And that makes sense. If I were to plot these points, 1 and 1, 2 is maybe here, 1, 4 is here. That's a vertical line, which by definition has undefined slope. So, and this is just kind of showing that any 2 points on that have undefined slope. Cool, cool. Any questions? All right. Talk about equations of lines real quick. The general form of the equation of a line is ax plus by equals c, where a is a positive whole number. I don't know why it necessarily has to be a positive whole number, but that's just the general standard form. It's like a convention. Just that's what everyone does. So that's why we'll do it. Slope-intercept form is the standard y equals mx plus b that is ingrained in your brains by this time. And then one that might not be as familiar is the point-slope form. If I'm given a point and a slope, I can tell you the equation of the line for any linear function. That's just, I take y as a variable minus the given y value equals the slope times x minus the given x value. A lot of the times you might see me write it as y minus y0 equals m times x minus x0. This is because it doesn't matter what y or x values you put. The y0 just to me means a given value. X0 also means a given value. So it says find an equation of the line that satisfies the given conditions. And so we'll have the given conditions here. It says write in point slope and write in slope intercept. So for example, if it passes through this point, 12, 10, with a slope of 1, first in point slope form, it's y minus my given y value of 10 equals my slope 1 times x minus the given x value of 12. So y minus 10 equals x minus 12. I just distribute that 1 in there. And then I move the 12 over plus 12. Oh, that should be 10 right there. My bad. 10. So I add 10. And then plus 10, I get y equals x minus 2. If I were to graph that on a graph, I would see that this is one of the points that I get. Cool, cool. And then in slope intercept, so I'll just write as SI, y equals, my slope is 1, so just x. And then I'm given this, I have just my y equals x minus 2 right here. So my x minus 2. So it's literally just copying down this. Like not even thinking about it, I resolved for y here. That's exactly what we were supposed to do to get the slope intercept form. I can do the same thing here. Y minus the given y value of 6 equals the slope, -5/6, times x minus the given x value. It's -2 minus -2 is the same thing as +2. I get a double negative. Cool. So y equals -5/6x, and then -5/6 times 2, and then +6. I just moved that 6 over. So I did 2 steps in once. I distributed this -5/6 into the parentheses, and then I added the 6 from the other side to get y by itself. Then I just simplify. Y equals -5/6x. This is -12/6. This is technically 36/6, right? If I multiply by 6/6. So 36 minus 12 is 24/6, which is 4. I just did a little jumping around because you could put this in your calculator. Conceptually, the main thing is that you understand this is the point slope form. I can solve it for slope intercept. Yes. 4 1/3. Oh, because this is 10, not 12. 36 minus 10 is 26. 26/6, yeah, is 4 1/3. Thank you for checking that. Again, you can just put this in your calculator. And that's a 6 there, not a 0. Cool. It says through 910 with undefined slope. This means that it's going to be of the form x equals a. Since the point here has 9, the x value equals 9. So in general, x equals 9. Right? I can't write y equals anything. And that's it. That's all I can do with undefined slope. I can't plug anything into the slope intercept or point slope form because I don't have a y value. Like I have a given y value, but my slope undefined means like division by 0. I can't write undefined slope in there. And then through to 0 with a slope of 0. This means it's going to be the form y equals b. I'm given a y value here. So my function is just y equals 0. If I wanted to, I could plug this into the point slope form. Y minus 0 equals 0 times x plus 2. Y minus 0 equals 0. Y equals 0. Really straightforward. Everything on the right-hand side goes to 0 because it's being multiplied by 0. So no biggie there. Cool. This is very similar. I'm given points. I can pick one of those points and do point slope, but I have to find the slope between them. I'll just write what the slope is between them because I want to. Actually, there's a bit too much for me to move on. So I'll just do this example and then we'll call it a day. Remember that slope is change in y over change in x. Here that's going to be 14 minus -2 over -3 minus 5. That's 16 over -8, which is -2. So all I did there was, given the 2 points, I found the slope between them. This is a question I like to ask on exams. What I'll do is I'll give you, the cost of 2 cups of lemonade is this much. The cost of 4 cups of lemonade is this much. Find the linear equation that defines the price of the lemonade. And so that's something that I love to ask. I think that's a very good question to test the ability to do this. So keep in mind a problem like this, like star this, put a sticky note or something. I love to ask questions like this. Cool. last semester in my class that I taught, there's a person that I don't like that I know in my life. So I poked fun at him by saying he was a bad person and sold fake Pokemon cards to kids. And that was the premise of the question, was if he sold this many fake Pokemon cards to kids and this many fake Pokemon cards to kids. And it was at like a really ridiculous price because they're kids and they don't know any better. So yeah, that was the problem I gave. And it was funny and I liked it. Cool. Now I want to do my point slip thing. Y minus, I'll pick this one because it has smaller values. That's literally it. I can give you any justification I want for picking either of the points. I just pick the one that has smaller values. So minus -2 is the same as +2. That equals 5, not 5. My slip is -2. -2 times x minus 5. So y equals -2x. This is +10 minus 2 is 8. So really straightforward. All I did was I just simplified this problem. That's all. I distributed the -2 to get a -2x and then +10. Now I subtracted the 2. Again, star this problem. I love asking problems like this. Cool. That's all I have for y'all. We'll pick back up on this Monday coming up from spring break. If you have any questions, let me know. If not, have a good, relaxing spring break. 1 second.